This is Jack Jackson back again, and in this video we're going to do some more exercises with measures of size and relative standing. So at this point, if you've been following along with my videos, you should be able to do these exercises on your own. So this is just a good check to see if you're on track and can do these things well by yourself. So I'm going to ask you to go ahead and as you see the questions, pause the video, answer them yourself, and then check your work as we go on with the rest of the video. So here's an example where we have some sales figures for automobiles, and you see a table here. So first question is, what day of the week is the dealership closed? Well, if you see you have sales figures for Monday through Saturday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, but no sales figures for Sunday, we can assume that this dealership may be closed on Sunday. Assuming the table, of course, is complete. So suppose you're a salesperson for this dealership and you get one day off each week besides Sunday, and you work on a commission, and you're trying to maximize your income. Which day would you choose to take off? Well, notice that I would probably take off on Thursdays if the only thing I'm worried about is maximizing my money, because Thursday has the lowest overall sales. So it looks like on average they're probably getting more or fewer customers on Thursday who actually buy an automobile. So it's going to be advantageous to take that particular day off as opposed to some other day. Okay, when do you really want to be sure you're there? Well, Saturday and Wednesday is pretty good too. So you want to make sure that you're there on those days for sure. So which one had the greatest sales? That would be Saturday. And if we do this as relative percentage, which we'll do in a minute, that's actually 30% of the whole sales for the whole week. Okay. Compute the total for compute the relative frequency here. And so if we add these up, we can add these up and get a total. I think this total is correct, I hope. And then compute the frequencies, compute the relative frequency for each day. So if we want a relative frequency table. So relative frequency means a part of the total, a proportion, part or proportion of the total, which is a fraction or a percentage, often a percentage, of the total. So for Monday, okay, oh, I'm sorry. You know what? What I had intended to do is actually this. I intended to do it this way. Let me change this. Change this slightly. Okay, what I intended to do was to give you this here, where it was only given by percentages to start with. Okay, and so still the same questions would go. Now what I said is, suppose that the total sales are this much. Complete the not rel. We're given a relative frequency table. Now get an actual frequency table. So how would we do that? We would multiply the relative frequency, 11%, that's 0.11, times this total here, and that would give you the amount for Monday, and take 0.17 times the total for Tuesday, and so forth. So see if you can go ahead and finish that table out. So here are the relative frequencies, and you figure out the frequencies. Okay. Now, before I go on and show you the answer to that, if we're going to make one thing we might want to do is make a circle graph or pie chart out of this. Okay. Now remember, there are 360 degrees in a full circle. So how would we figure out the angle? Now, to be honest, a pie chart is kind of a pain to make. First of all, to make it correctly, you must be able to make a circle. So if you're doing this by hand, you have to have some device to actually make a circle and locate its center, like a compass. Okay, or at least maybe you could trace around something that was already round, but basically you need something to make a circle and identify the center. So you need a compass to start with. Then, to get those, you need to compute the central angles, and then using those, you need to take a protractor and measure them out carefully. Okay, this is why we use technology for this a lot, because these are hard to do by hand. But here's what the angles turn out to be in degrees. Let me go ahead and put the degree symbol on there, because these are degrees. Okay. Now, let's take that and make a pie chart. So I want you to make actually two things. I want you to make a pie chart, or also known as a circle graph. And these angles here are going to be useful for that. See if you can make one by hand, or perhaps use something like Excel or something else to make it. And then also make a bar graph. Okay. Now it is appropriate for a pie graph because these totals do add up to, there are parts of a whole. And we're trying to emphasize these percentages of a whole, we might make a circle graph. So make a circle graph and a bar graph. So here's a circle graph or pie chart. And here's what it looks like. Now, by the way, what if I wanted to do that in Excel, which is the way I actually did that? Let me take this data here, copy it, and let's open up Excel. And I can paste that here in Excel. And I can take this data right here, select it, and let me pull this down where you can see the whole window a little bit better. Okay, I can take that data and highlight it, which is the actual amounts, or the percentages, either one. And then I can go to Insert, and I can insert a pie chart. You should never use a 3D pie chart. They very much distort the value. So never a 3D pie chart. People like them, but they distort the data drastically. So it looks like, for example, this blue wedge back here in the back is way smaller, for example, than the yellow wedge in the front, and perhaps they're not that much different. In fact, if you look, the blue wedge should be bigger than the other one. See how much difference that is? That's supposedly the same data. That's accurate representation. That's not. So we want to use we always use a 2D graph here. Now in Excel, then we can change some things if we want. For example, I can go to I right click on there and go to Select Data, and then for a horizontal axis, I can go to Edit and select them from here, and now that gives us a key down here. that's appropriate. Now I can go to, let's see, I can click on this and right click and say add data labels, and it will do there. I can change some of the shapes of the data levels. I can format the data levels, and I can put the category name in there as well. I can put the percentage as well, or I can and I can move these around a little bit if I want them all on the outside. And notice they have what these call leader lines, so they point to the right ones. Of course, if I've got them all labeled here, I don't necessarily need the key at the bottom. Of course, you want to write a chart title, which would be something like automobiles, maybe at the name of the company or whatever. You can also do some other things, like you can right click on this and you can format the chart area. There's kind of a pre-formatted one that we can select. And so anyway, you can play around with this a little bit, and so you get it to where it looks like what you want it to look like. So I'm just kind of experimenting with this. You can call out a sector like that or break it apart. I don't like that, so I'm going to undo. And so we can basically do something like that and make it look like we want it to do. So I think that looks prettier than what I had before, so I'm going to bring that over here and replace this chart with the new one. There we go. There's a pie chart. Even once it's in Word, sometimes we can readjust some things here. There we go. Okay, so that's a pie chart. However, I will claim that you really shouldn't use pie charts most of the time. They are good at showing slices of the pie. They're pretty good if you only have a couple of sectors here and you want to compare. But it's really hard to say compare the relative size here of Thursday and Friday, especially one that's over here at Monday. Those are harder to tell. They've got the numbers here, the numbers and the percentages, so you can compare those with the actual data, but it's a little harder to tell. An actual better thing is to look at the actual bar graph. Now, there's an order to the days of the week, so this is somewhat ordinal for the inputs here of the days, so there's a natural order to put those in: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday for a particular week. And then you see the sales here, and from this we get a much better idea of it. If we can make this prettier if we want, by changing some colors of the different parts. But in any event, we get this same thing. Now in Excel we can do the same thing here. Take the same data and go to insert a graph, and this time we can do what they call a column graph. It's a vertical bar graph, a horizontal bar graph. They call it a bar graph there. So let's do a column graph. It's better to not use 3D because that kind of tends to distort stuff. It's better just to stay with 2D like this, and then you can manipulate this in many of the same ways that we manipulated the other chart to make it look pretty and visually appealing. Okay, but of course we could draw this by hand. If you were doing this by hand, all you really need is some graph paper, and then where this is marked out evenly, try to decide how far up you're going to go and mark this off at an even scale this way. Draw your bars across here, and then just a ruler, or even just your your driver's license or an ID or a credit card you can use for a straight edge, and just draw these things out with the straight edge, and you can get a graph. So this is much easier to draw by hand. It's much easier than the pie chart. And if I spent some time making it look prettier, this would look just as visually appealing, and it's much easier to read. And now it's a lot easier to tell that there's not much difference, but a slight difference between Thursday and Friday, and that Monday's even a little bit higher. And it's still clear that this one forms a much bigger part of the total here on Saturday, and that Saturday and Wednesday are your big sales days. Thursday and Friday are very small sales days, according to this particular group. Okay, so a frequency histogram, the scale is the actual number here, and the relative frequency histogram looks exactly the same, change some colors, but it's the same thing. But now the scale is in percentages. You can also add data labels, which we've done here, which is a good idea if there are not too many of them, where you can actually put the actual amounts here on the top, or the actual percentages on the top here. So they're actually identical in the looks of the graph, but they're different in the relative frequency histogram and the frequency histogram are basically the same, but they're in appearance, but they're different in scale. This is measuring the actual dollar amounts. This is measuring percentages. In fact, you can do both. If you want one graph, you could put dollar amounts on this scale, put percentages on the scale on the other side, and you get both graphs at once if you want. Sometimes that's done. And you definitely should never use a three-dimensional pie graph. So here's another one dealing with cars. Let's say this is a GM club. Let's say we've got a club that's a bunch of GM owners, and they've got some classic cars perhaps. And in this particular one, there's 19 Chevrolets, 8 Pontiacs, 9 Oldsmobiles, 10 Buicks, and 4 Cadillacs. So what type of data is the input? Well, it's categories only, so it's qualitative. It's qualitative data. It is also the lowest level, categorical and nominal data. Okay, so not only is it qualitative, there's no inherent order to it, so it is nominal only. The output data is a count, so it's just a count, so it's discrete. So we have that. Okay, so the level is nominal, categorical. I'll just leave it as two questions there. I've already said it's categorical data down here. So, okay, so level is nominal. Categorical is another name for that. The output variable, frequencies or counts are always ratio because they're numbers. They have a natural order, natural zero, sums, differences, products, and quotients all make sense. But it's discrete as well. We're just doing counts. How large is the sample? Well, we need to add them up, and the total's already given is 50. So 50 are in the sample. Now, make the relative frequencies for these. Press pause. Okay, if you come back, we're just dividing all these by 50, and it's pretty easy to make them into percentages, and they work out exactly in this case. So those are the percentages. So that's the relative frequency. Now, a cumulative frequency doesn't make sense because this is not ordinal or higher. There's no inherent order. So here's a bar graph. We could also make a circle graph of the same thing, but we already decided that a bar graph is probably better. So from this, for example, you can clearly see that there are more Chevys than everything else. Cadillacs are the least, and so forth. All right, new problem altogether. The ages of 50 dancers who responded to a call were recorded and given in this thing here. So we have 17, 18, 19, 20. Less than 17, we didn't have any. Up to 24 was the total. So they're 17 to 24 with their ages, and these are the percentages here. And it's 50 dancers. So see if you can fill out the rest of this table given just that much information. Go ahead and do it on your own. Press pause now. So if we know the total is 50. So of course there's 0 here. If that's 2% of the total is 17 years old. So it's 50 times 2%. That's 50 times 0.02. Okay, times 50 is how many is that? Just 1, isn't it? Okay, and then this would be 3, 16, and so forth. Okay, so you can fill that out once you finish it. Cumulative frequency is kind of keeps a running total. 0, 1. So 1 is 0 less than 17. 1, 17 or less. 4 from 18 or less. 20 for 19 or less. And for the cumulative relative frequency, take the total cumulative frequency and divide by 50. And this is 2% here. And then 4 is actually 8%. 20 is 20/50ths, that's 40%, and so forth. Okay, I'll show you the completed table here in just a second. Here's the completed table. Pause that if you want to look at it for a minute. Make sure you understand where all those numbers came from. In this table, the black numbers were given, and the blue are the ones we computed. Actually, the 50 was given as well. Now, if we do an ungrouped relative frequency histogram for this data, can you do that? It's going to be essentially just like a dot plot, more or less, except bars instead of the dot. Do that now. Press pause. Okay, and so here we go. Now, technically speaking, on this, since it's ages, 17 is actually at the edge of this bar, and 18 is here, because anything between 17 and 18 we round down and include it in the 17 bar. Normally, 17, in most data, 17 would be anything from 16.5 to 17.5, which is kind of what this looks more like. But ages, we do it a little bit differently. But anyway, those are the bars, and we got a bar for each one. Since I said a relative frequency histogram, the scale is percentages. And we have ages, and there's an order to it. So this is the order we want to go. And increasing order is how we typically do a horizontal number line. Okay, prepare an ogive for this. Ogive. Okay. Remember what that is? That's a cumulative frequency broken line graph. Press pause. Here it is. So, well, I started at 16. There's nothing 16 or below, so that it starts at 0. 17 we have 1 or 2%. 18 we're up to 8%. 19 we're up to a total of 40% at 19 or below. 60% is 20 or below. 21 is 84% at 21 or below. All the way up to 24, we've made it up to 100%. Of course, it would stay at 100% there, stay at 0 here. So this is a cumulative frequency here, cumulative relative frequency actually. Okay, this time I'm going to give you the graph and have you interpret it. This is a breakdown of medical expenses. And I've told you that this covers an annual expenses of $3,456,782. What's the single largest area of medical expense? Well, it's real easy to see that the doctor's personal income is going to be the biggest thing. You're paying for their expertise, and so that's where most of the money goes in this particular one. Not only is it the largest one, it makes up over half of the whole thing, which you can clearly easily see. It makes up 56%. How much did it spend on income for doctors and non-physician personnel altogether? So how much did they spend on salaries? Well, if you look, none of these are salaries up here. Non-physician employee here, doctors personal. I'm not sure about this employee physicians if that's included or not, but this is income here. So we're going to add those two for sure, and maybe that one as well. Okay, and so we add those together. I'm saying it was only these two. So if we add those two together, 56% plus 16%, 72%. That's 72% of the total. So you take that total times 72%, make it a decimal, and we get this much is spent for personnel cost. If this employee positions is personnel cost, then we got even more. Okay, let's do another one here. In a survey of 20 patients who smoked, the following data were obtained. Each value represents the number of cigarettes the patient smoked per day. Okay. Make a dot plot of this data. Press pause. Come back when you finished. Okay, there's the dot plot there. So you can kind of see how they're spread out, where they're concentrated. Notice you got a number line scale here, and you have a dot for every data value. How about a stem and leaf plot for this with one line per stem? So we'll make the units digits be the stems. Okay, try this on your own and come back. Here's what we should have. So this means that the 0 stem means these are single digits. So there's a 5 and a 6 and an 8 and a 9, and there's these in this line have a stem of 1, so 10's digit at once. This is 10, 11, 11, 11, 12, 12, 13, 13, 14, 14, 15, 15, 16, 17, 18, 19, and this one down here is 22. Now that's kind of too few. A lot of them are all here on this one, so we get a better idea if we break it into more stems, so more lines per stem. So the 0 line is going to be, so anything that's in 0 to 4 will go on the first stem, first line, and then 5 to 9 will go on the second. That breaks it into 5 possible digits for each one. So we break that up. This looks like this. Now the upper 20s and the lower units, there weren't any there, so this actually turns out to be this. But it did break nicely up this. So the lower teens are here, and the upper teens are here. Now do one with 5 lines per stem. So 0, 1 will go in 1. So look at the 1s here, 0s and 1s here, 2s and 3s here, 4s and 5s here, 6s and 7s, and 8s and 9s here. Notice we had a blank one here because there weren't any 0 1s there. That sometimes happens when you're doing a stem and leaf plot. Sometimes it will show the gaps. Do a frequency histogram using 6 classes. So next we want to take this data and make a frequency distribution table and histogram using 6 classes. Okay, so let's see if we can figure out how to do that. See if you can do it on your own and come back. Press pause. So notice the data in order goes from 5 to 22. So there are 18 possible natural numbers from 5 to 22. When you're doing that, you subtract and add 1 will count up all of them. So that's 18. Of course, you could use an ungrouped histogram. That would be 18 groups, individuals. But any so if we divide that by 6, that would be 3 each. So for example, 5, 6, and 7 would be one group. 8, 9, and 10 would be another one. And so these are the groups. Now those groups are sometimes called bins. Okay, so we have our bins here: 5 to 7, 8 to 10, and then we see. So 5 to 7, there are 2. 8 to 10, there's 3. That's 8, 9, 10. 11 to 13, 11, 12, and 13. So there's 1, 2, 3, 4, 5, 6, 7. 14 to 15 is 5. 14 to 16 is 5. 17 to 19 is 3. And then the last group has 1 in it there, from 20 to 22. So there's one way we could do it, and then we could do a histogram based on that, like this. Okay. Now the mode we would find by looking at the original data, and the mode is actually 11. There are more 11 than anything else. We can see that on the dot plot right here, so it's the highest one. We can see it in the stem and leaf plot, but it's the most repeats. So 11 is the actual mode. When you have this, when you have a grouped frequency table or a group relative frequency table, because it's grouped, we can't tell whether these 6 things are 11s, 12s, or 13s. It's actually all those together. We can't tell which one's the most, but we can get the modal group. So the modal class is 11 to 13. We can do that, the modal interval. The actual mode's 11, which is in the modal class. Okay, new data set. Let's look at a couple more here. Actually, let's go ahead and just stop the video now. We'll come back and get the rest of these next, I think I've got 7 more problems that we'll do in the next video.